Hi everybody. Video notes on graphing systems of equations. So we have learned how to solve a system using substitution and elimination, which are the algebraic methods. Today we're going to look at graphing in order to solve. So just as a reminder, two or more linear, or actually any equations involving the same variables form a system of equations. The solution set for the system is a set of ordered pairs that satisfy both equations. Let's take a look at the graphing method. Here we have two equations. They're both linear because x is to the first power. Remember, when x is to the second power, it's quadratic. But here x is to the first power. These are both linear. So they're both graphed here. Both lines are graphed. And the solution is the point where they intersect, which is 3, -1. That is the solution set for the system of equations. Let's take a look at another possible solution. That's one solution. Okay, here we have two lines. They're graphed over here, and they do not intersect. They have no points in common, neither of these lines. So we would say no solution. Over here, we have two lines. We graph both of them and notice they're the same line. Remember, this is called coincidental lines or coinciding lines. And since they share every point, they have an infinitely many solutions if they're the same line. Okay? Those are your three options for systems of linear equations. Let's take a look. Use the graphs below to determine whether each system has one solution, no solution, or infinitely many solutions. So take a look at number 1. Here we have one solution. Okay? And it does say if the solution has one solution, name it. So this solution is 0, -1. That's the solution to this system. Remember, it's where the two lines intersect. Okay, the second one, here we have one solution, and the solution is 3/5, 4/5. Here we have parallel lines. So in this case, we have no solution. Why? Because they do not intersect. And here we have two equations, so that means there must be two lines here. But we only see one, which means they're the same line. They're coinciding. So we have an infinitely many solutions. Infinitely. Okay? So let's look down below. It says, graph each system of equations on a separate sheet of paper, then determine whether the system has one, no, or infinitely many. If the solution has one solution, name it. Remember, naming it means give me the coordinate or the ordered pair for that point. So let's take a look at number 5. Well, we want to graph this. My tendency here is to use the elimination method, because if I eliminate, if I subtract the x's, they disappear. But since it says to graph, we're going to need to put these into graphing form. Remember, graphing form is y equals mx plus b, which means we want to isolate the y in this problem. So let me get another piece of paper so I can have a little bit more room here. Okay, so for the first equation, we're going to go ahead and put it into slope-intercept form for easy to graph. So we want to isolate the y. So the first thing we want to do is cancel out the 4x. So we're going to subtract 4x. Remember, what you do to one side of the equation, you do to the other side. Okay, 4x minus 4x is 0. So we bring down the negative 2y. These are not like terms, so we write them separately. So negative 4x plus 4. Since 4 is positive, we put plus 4. And then we divide by negative 2. These should always be the same. Divide everything by negative 2. Negative 2 divided by negative 2 is 1. So we get 1y equals 2x minus 2. So there's our first equation. Let's do the second one. So we have 4x minus 2y equals 0. Again, subtract 4x on both sides. We get negative 2y equals, we put the negative 4x first and then the 0, but we don't have to put plus 0 on the end. Divide by negative 2, unless you want to. Negative 2 divided by negative 2 is 1. Y is going to be equal to 2x. Okay? So now we want to graph this. So let me make a little graph here. Okay, so here we go. Here we have some graph paper. Please go to Walmart and pick up some graph paper. It'd be very helpful. Here we go. So graphing the first one, remember we start with the y-intercept. So negative 2 is your y-intercept. And then we graph our slope. So we want to put our slope into rise over run. So we're going to rise to, run, positive 1. So from our y-intercept, we rise to, we run positive 1. We rise to, we run positive 1. We rise to, we run positive 1. And that is the equation for our line. We can then connect our dots. And that is this line. Let's call it y sub 1. Okay, let's graph the other one now. So the other one has a y-intercept of 0. So 0 is our starting point. Our slope is 2 over 1. So from our starting point, we rise 2, we run 1. We rise 2, we run 1. We rise 2, we run positive 1. Okay, let's take a look at this one. All right, what do we have here? What kind of solution do we have here? Do they intersect? Nope. So we have no solution. Why? Why? Correct, the lines are parallel. The lines are parallel. Those two, if you remember from geometry, that means parallel. Okay, so you could have figured this out by looking at the two equations. Do you notice anything about the two equations that say, hey, these lines are parallel? Look at the two equations. Anything they have in common? If you said the slopes are the same, you are correct. The slopes are the same. Remember what same means? Equal. The slopes are the same. Therefore, these three dots mean therefore, lines are parallel. Sorry for the light colored, I just wanted to change the color a little bit. Okay, so that's how you solve by graphing. So number 6 is real nice. It's already set up for us to graph. You know, if I was you, I would check my slopes right off the bat, because if they're the same, I know the answer. If the slopes are the same, the lines are parallel. Now, if the y-intercepts are also the same, then they're actually the same line, and they would be coinciding lines. Okay, but the slopes are not the same. So these two lines are going to intersect. They're going to intersect. Remember, you have to put your equations into y equals in order to graph them. So I'm going to go ahead and stop right there. Why don't you try this one on your own, and then I'll check your video notes tomorrow and see if you got the right answer for number 6. Have a good night.